Have you ever really thought about the journey your milk takes before it hits your cereal bowl? It's easy to just see a carton in the fridge, but behind that is this incredible, unseen world of engineering. Today, we're diving into that world, a place where science and design come together to protect what's often called nature's most complete and delicate food.
I mean, seriously, just picture that for a second. It's pretty gross, right? The thing is, even the highest quality milk, fresh from the farm, can be completely ruined if the equipment it touches isn't absolutely perfect.
So what's the secret? What's the invisible force field that keeps our milk safe and pure? Well, the hero of this story isn't a person or a single machine, but a whole philosophy of design. And that answer is something called sanitary design. It's this core idea that every single piece of equipment that milk will ever touch has to be built with hygiene as the #1 non-negotiable priority. So how do they pull it off? Well, it all starts with a set of golden rules. Okay, let's get into it. These are the golden rules of design, the fundamental principles for engineering total purity. And these aren't just, friendly suggestions. They are the absolute laws of the land in a dairy plant. At its heart, sanitary design is a way of thinking. It means that before an engineer even finishes a blueprint, they're already asking, how are we going to clean this thing? It's all about preventing problems from ever happening in the first place. Think of it like this. The goal is to create a system with absolutely zero hiding places for bacteria. Every surface is smooth, every permanent joint is welded and polished, there are no tiny cracks, no hidden threads, no dead ends where nasty stuff can hide and multiply. When it's time to clean, everything gets cleaned. Period. And this obsession with cleanability goes beyond just the parts that touch the milk. Take this number, 100 millimeters, or about 4 inches. That's the mandatory gap between any piece of equipment and the floor. Why? So you can get under there and clean properly. It just shows you how comprehensive this philosophy really is. Nothing is left to chance. All right, so we've got our rules. Now it's time to build the superhighway that the milk is actually going to travel on. And believe me, this is no ordinary plumbing. This is a high-tech network built from some very, very specific materials.
When it comes to dairy engineering, stainless steel is the undisputed champion. It's tough, it doesn't rust, and you can polish it to be incredibly smooth. But, as you're about to see, not all stainless steel is created equal.
Okay, check this out. At first glance, 304 and 316 look pretty similar, but the real game changer is right there in that last row, molybdenum. That tiny 2 to 3% addition in AISI 316 is the secret sauce. It makes the steel super resistant to the harsh chemicals used for cleaning. That's why it's the go-to for things like cleaning tanks. Now, steel is the star of the show, but plastics play some really crucial supporting roles. And the key difference is their structure. Think of thermoplastics like strands of spaghetti. You can melt them down and reshape them, which is perfect for things like flexible seals. Thermosetting plastics, on the other hand, are more like a woven net. Once you heat them, their structure cross-links and locks in place for good, giving them the strength you need for something like a gear. Okay, so you've picked out all the best materials, but that's only half the battle. Because the most expensive, perfectly designed parts in the world are totally useless if you don't put them together in exactly the right way. And there's a clear process for this. You start with a detailed blueprint. Then you pick the right size for your pipes. Go too small and you'll have flow problems. Go too big and you're just wasting money. Step 3, you connect everything, always choosing a smooth weld over anything else. And finally, you support the whole structure so it doesn't bend or sag over time. Now this might be one of my favorite details in the whole system, because it's so clever. Every single pipe is installed with a tiny, almost invisible slope. We're talking less than 1%, but it's just enough to let gravity do all the work, making sure every last drop drains out after cleaning. No puddles, no pockets, no problems. And to make sure that perfect slope actually works, you have to think about this. The level of detail here is just brilliant. As the pipes get bigger and heavier, you need to place the supports closer together. It makes perfect sense, right? This prevents the pipe from sagging, which would create a low spot, and totally defeat the purpose of that careful sloping. This is exactly why component selection is so critical. A standard gate valve like you might find in your house has all these little internal nooks and crannies. You can never get it fully clean. So in a dairy, you use special sanitary valves, like a ball or diaphragm valve, that have a completely smooth, open path for the milk and the cleaning solutions. So after traveling through that pristine superhighway of pipes, the milk finally arrives at its temporary home, the storage tank. And these aren't just big metal cans. They are highly engineered safe havens designed to keep that milk perfect. A modern milk tank is basically a giant, high-tech thermos. You've got 3 layers: a super smooth, sanitary stainless steel shell on the inside, a thick layer of high-efficiency insulation in the middle, and a tough outer shell to protect the whole thing from the outside world. All right, let's take a quick tour. Milk comes in gently through a non-foaming inlet. A slow-speed agitator keeps the cream from separating. There's a vent so it can breathe, a spray ball for automated cleaning, and get this, even the interior corners are rounded to a specific radius, all to make sure it can be cleaned perfectly. Every detail matters.
And here's the proof that all that engineering works. A well-built tank has to meet this incredibly strict standard. Over an 18-hour period, the milk inside cannot warm up by more than 2 degrees Celsius. Just think about that. That's how effective these safe havens are.
Now, these tanks really come in 2 main styles. You have the horizontal tanks, which are great for inside a plant, but when you need to store a truly massive amount of milk, you go with vertical silos. These are often so big they have to be located outside, and instead of a mechanical mixer, they use puffs of filtered, compressed air to gently stir the milk.
And it's so important to remember that the plant is just one stop on a much longer journey. These same principles of sanitary design, the smooth steel, the high-tech insulation, the perfectly cleanable parts, they apply to the entire chain. From the cooler on the farm, to the tanker on the road, to the rail car crossing the country.
So if you take one thing away from all this, let it be this. In dairy engineering, nothing is an accident. Every single weld, every curve in a pipe, every gasket, it's all a deliberate, calculated choice made for one single reason: to protect the milk.
It's this amazing, invisible journey that happens every single day all over the world. A true marvel of engineering that makes sure the milk in your glass is just as pure and safe as it was the moment it left the farm. So hopefully, the next time you open that carton, you'll have a whole new appreciation for the trip it took to get there.